Right, if we were to calculate 0.1 cubed, we can think of 0.1 as being 10 to the minus 1. If we want to cube an exponential, we can actually do it by doing the multiplication. So we can do it by doing 10 to the minus 1 times 3. 10 to the minus 1 times 3 is 10 to the minus 3. So it's telling us that our answer is going to be 0.001, or 1 divided by 1,000. So this is another rule with potentials, that when you cube them, you are actually allowed to multiply the numbers. If you're not familiar with doing that, you can actually see that 0.1 cubed is 0.1 times 0.1 times 0.1. 0.1 times 0.1 would be 0.01. 0.01 times 0.1 would be 0.001, giving us the same number. Or this can also be thought of as 1 to the 10th multiplied by 1/10 multiplied by 1/10, which is the same as 1/1000, which is the same as 0.0001. So when it comes to potential form or scientific notation, there's a lot of normal ways to do it as well. But you're trying to improve your skills in being able to manipulate it directly from the scientific notation. So 0.1 cubed would give us the answer 0.001, in whichever way we do it. What about 0.01 squared then? Well, in scientific notation, that would be 1 times 10 to the minus 2, and we're trying to square the number. I know that when I'm squaring the number, I can use the skill of 1 times 10 to the minus 2 times 2, which will give me 1 times 10 to the minus 4. That is the same as 0.0001. 1, 2, 3, 4 places back the decimal point that's been moved. Or 100, 1/100th over multiplied by 1 other 100th is the same thing. I'm going to give you 1/10,000, or 0.0001. So these will all give you the same thing, but this method saves you time. Here in the next question, we have 3 cubed minus 2 squared. 3 cubed minus 2 squared. Now I've said that when you've got them in the exponent form and you have a subtraction sign in between, you're never allowed to try and do anything with these powers. You've got to work out the numbers. So 3 cubed would be 3 times 3 times 3. 3, 9, 27. 2 squared, 4. So we end up with it being 27 minus 4. We've got to work the numbers out and then do the subtraction, giving us the answer, 23. So when we have additional subtraction with exponents, we actually have to do the calculation and then finish with the subtraction when you've converted it to normal numbers, always. Okay, what about if they give us a number like this then? 700 times 10 to the power 4. This one is in potens form. And they'd like us to convert it to Grundpotens form. That means we've got to turn this into 7 times something. So let's think about what 700 is. 700 is just 7 times 100. And keep the 10 to the 4 the same. Now we know that 10 to the 100 is really the same as 10 to the 2. 10 squared. So we get 7 times 10 squared times 10 to the 4. 10 squared times 10 to the 4 is the same as 7 times 10 to the power of 2 plus 4. 7 times 10 to the power 6. Giving us 7 times 10 to the power 6. This now is in Grundpotens form. As you get used to it, if you've done it a few times, you'll see that you're moving the decimal place 2 places back, so you just add 2 to that number there. But until you get used to that technique, I'd like you to try and set it up like this. Okay? So if I was going to do it that's experienced and have done these a lot, I would look at 700 times 10 to the power 4. I'm going to be moving my decimal point 2 places back. So if I'm moving it 2 places that's going to go up 2, so I would get the answer directly. But to understand how you get the answer, you have to actually start by splitting it up into its different factors. 700 is the same as 7 times 100. 100 is the same as 10 to the 2. 10 to the 2 times 10 to the 4 is the same as 10 to the 6. So you need to practice these techniques. Okay, if we were to then look at 800,000 times 10 to the 6. This number isn't really very useful because we've got really no idea of how many zeros there are there properly. There's 10 to the 6 here and then there's a load here. How many are there in total? Well, this is the same as 8 times 10 to the power 1, 2, 3, 4, 5 times 10 to the 6. This number here has just been rearranged into 8 times 10 to the power 5. Now this is really easy because now we have 8 times 10 to the power of 5 plus 6, giving us 8 times 10 to the power of 11. So we can use this technique to turn numbers into scientific notation pretty easily. Let's look at some other things that they expect you to be able to do. And that's to turn them and put these prefixes in the front. If I was to say that I had a nuclear power plant that generated 1 gigawatt of energy, okay? 1 gigawatt of energy. What would that say to you? Nothing if you didn't understand what the term gigawatt meant. Okay? So whenever you see the letter G, it actually means replace that letter with its real number. It means 1 times 10 to the power 9 of what? It's that simple. You're replacing the letter here with what that prefix means. The letter G in maths, big G, always means times 10 to the power 9. Okay? So if they ask you to convert hectograms into grams, we know that 5 hectograms is 500 grams. But we also know that hecto means times 10 to the 2. So we could replace this letter hecto with 5 times 10 to the 2 grams. So we've already got it here. We don't actually have to convert it first to grams and then 5 times 10 to the power 2. We can go and replace the letter H with the times 10 to the 2. We get the number of grams directly in scientific notation. So if we were to look at 9.1 megawatts, we would convert the letter M into its real term. Mega in the table means times 10 to the power 6, always. Times 10 to the power 6 watts. So we've already converted megawatts into exponential form without having to multiply everything through. Last one, 1.5, no, 2 more. 2 millimeters into meters then. How would we do that? Well, of course we could convert it. We know how to convert millimeters into meters by just dividing by 1,000. But we would like it in meters. Well, we take the word milli, which we know means times 10 to the minus 3. So we would convert that, the word milli, into times 10 to the minus 3 meters. So 2 millimeters, using this technique, is 2 times 10 to the minus 3 meters. What about 1.5 micrometers then. We'd like it in meters. We keep the 1.5 the same, we keep the meters the same at the end, and we put in times 10 to the minus 6 wherever we see the letter micro. So 1.5 micrometers is the same as 1.5 times 10 to the minus 6 meters. And in 9th grade on your formula sheet, they'll often give you these ones. But knowing this technique of replacing the letter with its exponential form makes your calculations much easier.